you guys see that?
Yep.
Yes.
Yeah.
Okay, great. So this is the website, first of all. It's automunge.com. This has links to the blog, which we've been kind of documenting the development over the last few months with regular blog posts. We've also have a link to the GitHub. So it's licensed open source, and it's available for pip install. And then we also have a link to the Twitter account if you'd like to follow us. So that's automunge.com. And then just to run through a quick demonstration.
Are you doing that by yourself because you say us, or is it you and your company, or?
Yeah, you know, as the Big Lebowski likes to say, you know, the royal we. It's,
Okay.
I'm the sole proprietor.
Okay.
It's a Python package. This is I've already have it installed, and you just import the package, and you know, set it to some, you know, AM just for simplicity. This is a kind of a tool I use for developing, which is just a small data set. This is kind of just arbitrary data intended to have a column for an ID column, a column for numerical value, a column for a binary value, a column for a categorical value, and a column for a time series value, as well as a column for labels. So this isn't a real training set you could use to predict anything, but it's a kind of a development tool, just because I wanted to get something in front of you guys quickly, and I can do this with a real data set too. I've done some demonstrations on Kaggle data sets on my blog, for instance. But the way the tool works is you define, here we have our data set. Now, basically, this is the function call. And all of this is just not necessary. All you really need to do is run it on the train set. But there's a series of option calls that can be incorporated for different options. And it's all documented on GitHub. But the idea is you assign the output of this function call to a collection of sets, which are intended to be the generic sets used for some machine learning problem, including a train set, the ID labels for a train set, and the predictive labels for a train set, as well as the validation set, the ID values for a validation set, and the labels for the validation set. And there's actually two different validation sets, one for hyperparameter tuning and one for one for final model validation. So you can set your validation ratios to whatever percentage of the value you want. So you can set it to 20% or 10%, and it carves out an appropriate amount. And if you want that to be pulled from the bottom of the data set, you don't shuffle. And if you want just random points for your validation set, you can shuffle it. And then, you know, it also outputs a test set, a test ID, and then some, this is a dictionary which helps to reverse encode predictions. So if, you know, the idea is that the labels are processed consistently to the training data. And then if you have like a categorical set, you want to reverse encode it back to the labels, then this is the dictionary to do that with. And then a list of the columns that are output. And this is a dictionary which is used for a subsequent call to process any downstream data that you didn't have at the initial application. So the idea is you can process your train data and your test data simultaneously, or if you don't have your test data, just your train data by itself. And then if you later get some new data that you want to process consistently, you use this save dictionary for a separate function call that I'll show you. And then when we call the automunge function, we pass this data frame. It works on data frames. and you pass the train set and the test set. You designate which columns are associated with labels, ID values. You call whether, if you want to change your validation percent, which will be the amount of the set that's carved out for validation. You tell it if you want it to shuffle. You tell it if the train label frequency level is a way to allow for this is actually a specialized method that I'll cover in the documentation. I won't go into it now. It also allows for a power transform for all positive numerical sets. It allows for you to transform numerical sets into bins based on deviations from the mean. It allows you to do the MNL infill technique, which is a way to predict infill values for missing points in the set. And I guess I'm kind of going to a little too much detail. I apologize. I should probably come up with a prepared speech. I'm just kind of running through all the details. But in summary, when we run this function, the output is these columns, which, if you remember, we had a single categorical shape column, and it outputs a one-hot encoded set of, ones for circles, ones for ovals, one for squares. It outputs bin sets for a number of standard deviations from the mean for the numerical column. It outputs binary ones and zeros for the binary column. It outputs segregated by timescale date values for the timescale column. And it outputs both the power law transform and a z-score normalized numerical set for the numerical value. And what that looks like in practice is this array of numerically encoded values. And so what this is accomplishing is we're basically taking some arbitrary data, which, as you can see, is both numerical and categorical and time series and all of that, and we're automatically forming it into a form that can be fed directly into a machine learning algorithm. And so, what this NumPy array represents is the values for this collection of columns. So this is the columns, and the way the column labeling is set up is such that the suffix on the column label is meant to designate what feature engineering transforms were applied to that column. And so by looking at this, we know that the first column is the one-hot encoded binary indication for whether the categorical value from our data set was a circle, square, or oval. And so what that means is that in our outputted array, this was not a circle, this was set to 0. So these are one-hot encoded for, and so this is, so these are the three values associated with one-hot encoding for the categorical. And so that shows that for that value, this was a square.
And you can also generate a pandas data frame out of this again.
Yeah, absolutely. Yeah, so cool. Using this list of columns and using that array, you can just transform it right back to a pandas data frame if you prefer. Yeah. And what it's doing is it's using the properties of each column. It's evaluating which type of transform to apply, and it doesn't just do one column input to one column output. It can, for categorical sets, for instance, generate a series of one-hot encoded columns, and for numerical values, it actually generates a whole series of child columns, including bin sets for deviations from the mean, as well as z-score normalized numerical values, as well as power law transform numerical values.
And you can also tell it to not one-hot encode. If you want to use embeddings, for example, then you shouldn't one-hot encode?
Yes, absolutely. Yeah. So the idea is that there's a simple call right here. Any columns you want to exclude from this application, you just list in this exclude transform columns. And so this is intended as kind of like the final step before applying machine learning. And it's not intended yet as a replacement for feature engineering. And certainly there's types of feature engineering that aren't incorporated here. And so if there's any other supplemental feature engineerings that are performed, you just exclude it from the transforms, and then that can be it.
And I mean, feature engineering is always, at least to some degree, going to be domain specific. So probably you cannot incorporate any feature engineering that's possible, right?
Yeah, well, it's there's some types of feature engineering that are a little more generic, like
sure.
But this is meant to address those that are kind of the most generic, and generally for a numerical set, it helps to run some type of z-score normalization, and it helps to know the deviations from the mean, and it helps to know if it's a subject to a power law distribution, some type of power law transform. So those are kind of generic transformations that will generally always help, and so this automatically runs that. But a really neat feature that I haven't talked about that is kind of one of the defining features of the product is what's called ML Infill, and the idea is that the machine learning through the application of this tool for cases where we have missing values in the set. The tool uses machine learning to derive properties from the rest of the set and predict infill for missing values. So that's kind of a unique feature, and it differs from mainstream practice of doing things like plugging in the mean value for a set or plugging in values from an adjacent row, for instance. And it's done in an automated fashion, and it's done such that the same model can be used to predict infill for missing values in your train set or any subsequently available test data.
So are you able to determine exactly what that is, though? Because often when you use missing values, you might assign it a certain value, and then you know what that is. In your instance, you said that that's automatically generated. How do you actually identify those missing values?
Sure. So one of the rows or one of the columns that'll be output for each column, parent column, is a column we call the NA row. And this is just a Boolean identifier for any rows, for any cells that were subject to infill.
Okay.
And do you have something in place to check if non-values contain any information? Because I've seen several cases where under specific conditions in a certain measurement, nonce were produced, and that was actually valuable information.
Do you mind repeating the question?
So I've seen several cases where non-values that were created, for example, by sensors. So the conditions under which these nonce were produced are actually valuable information for the model. I've seen several cases where that's true.
Yeah.
So it's not always good to replace non-values.
That's definitely a valid point, and that's the ML infill is an optional feature. It can be turned on or off.
Yeah. But anyway, that's a very, very interesting tool. I've just scrolled through the automunch.py file, and there's a hell lot of code in that file.
It's so again, I recommend the website, automunch.com. It's if you're interested about the tool, we've been publishing. Sorry, we again. I just use that when I write, and then when I talk, it just comes right out. I've been publishing several essays on Medium, and actually, this is kind of the culmination of of a book that I wrote that I just completed. The name of the book is From the Diaries of John Henry. It's kind of creative nonfiction, and it addresses themes of machine learning, as well as physics and movie reviews and all kinds of stuff like that. But the series of essays associated with the AutoMunge tool is all collected in one spot, linked on the blog. And then the GitHub account, if you want to learn more about the tool, I would direct you to the README file. And that kind of has kind of full documentation for all of the features of the tool.
Are you planning to monetize this project in any way? Do you see a way of actually doing that? Because I'm guessing that's what you'd like to do, given you put a fair.
Yeah, I certainly have some thoughts on that. I think the first step is trying to get this in people's hands, and it's intended in this iteration as a free tool to provide value to the machine learning community. And if we can later build on top of that some commercial offering, that is the goal. But at this point, it is a free tool that is available in open source.
And you're also welcoming contributions if someone wants to.
Absolutely, yeah. So I do appreciate the opportunity to share. It's this obviously was just a kind of an artificial data set that I was demonstrating. But if you go to my blog, I've been demonstrating some other sets as well, and it's probably about time I put together a demonstration tutorial. But this is all the documentation is on GitHub, and yeah, this has been a project that I've been working on for a few months now, and it's intended to automate the final steps of data processing prior to the application of machine learning in summary.
Cool, great, thanks.
Very nice tool there.
Just a quick one. When it comes to things like categorical variables, can you actually specify whether a column is a categorical variable, or does it automatically infer it?
Yeah, you can. There's a pass for that. It's forced to categorical. So you just list the name of the column here, for example.
Okay. Because I mean, some of this is, I don't know if you've ever tried AWS's machine learning module. So they've got that on the AWS cloud. Some of this is available there, and you basically it's just a click and choose, and so that makes things quite easy. But clearly, your differentiator is things like the ML infill. So that's really nice to see. Have you ever tried the AWS machine learning module?
I mean, I've experimented with a lot of tools, so I'm not an expert on the AWS tool.
Okay.
Can you also bucket numerical variables to categorical?
Can you bucket? Do you mind repeating that?
Yeah, so defining buckets for numerical columns, and so that each one is, so for example, if you have between 0 and 10 is bucket 1, and then you sort all of those in bucket 1 and can
so the intent
categories for that.
The tool is designed as a framework in which different feature engineering transformations are currently available, and based on what I found to be like some of the most basic transformations. But the intent is to continue to round out the range of feature engineering transformations, and I definitely see that as one potential development path. That one is necessarily well suited for an automated address because you would have to specify the buckets, but maybe there's some means where we could specify percentage ranges. I don't know. It's something we have to think about.
Yeah, you have to at least specify the rule how to create those buckets. You can take different distributions or just a linear range or something.
Hey, if you have any ideas, it's something we could implement. Let me know, and we can.
Yeah, sure.
Nicholas, it kind of seems to me, correct me if I'm wrong here, but you have kind of reinvented the wheel, right? So, I mean, I come from biostatistics, and there's a huge plethora of literature actually on multiple imputation and so on, and data pre-processing. So, I mean, you could have copied. It seems to me, correct me if I'm wrong there, but you could have copied a lot of stuff from there.
Yeah. Well, part of the challenge was making this work in the context of the ML Infill technique, and so that did require reinventing a few things.
Okay.
But it's, it's not always, reinventing the wheel is not always bad, because when you create a better API for programmers, that's very valuable.
Yeah, and it's, the whole intent here is to make this an automated process. All that we're doing is feeding some data set into the automunch function, and the rest of it is automated. We don't tell it which columns to do a categorical one-hot encoding. We don't tell it which columns to do numerical transformations. It infers that based on properties of the data.
Yeah, and what's nice about that is, for example, you've got a whole lot of data, and instead of having to wait maybe an hour or 2 hours before you're actually ready to predict something, you can probably do it in 5 minutes.
Yeah, and it's, it's certainly true that a little more there's feature engineering transformations that will probably give you a better model than just the basic stuff that's presented here. But this will get you up and running quickly, and it's, even if you're doing some really elaborate feature engineering address, this is still suitable for the final steps. And it's it's not meant to replace feature engineering, but it is meant to become the final steps before the application of machine learning.
Great. Just out of interest, how long has this been in the works for? How long have you been working on this project?
I think since late August, I'd say.
Okay. Nice. Well, thanks for sharing. Just another quick check. Is there anyone else who'd like to demo anything? I think, well, two things really. Is anyone else have anything they'd like to demo today, or even perhaps next week? Because I know that we'll probably need some projects was demoed, or just talk about something next week. So either of those two options. Let me cover the first one. Anyone else want to demo anything?
Can I just say one final thing?
Yeah, sure, go for it.
So one of the challenges of building a software tool is getting the word out. And if any of you guys, feel free to share on social media. Feel free to share with your friends. It's automunch.com, and so it's. I don't exactly have a large community of users at this point, but that's the hope. So any. Have
you got a link on the Fast.ai forum?
No, that's an idea.
Yeah, so, that's probably a good place.
Okay, appreciate that. Thank you. Thanks.
Okay, anyone else? Anything else they'd like to share today?
Does any one of you guys, or has any one of you guys read the book Weapons of Math Destruction by Casey O'Neill, I think was the name? No, because today I heard a podcast. I mean, it's just to chip that in real quick for, I don't want to disturb any prepared presentation, just for you to think about this in advance a little bit. I heard a podcast today with her, and basically her point was, I mean, that was discussed the last time. The nature of how algorithms can basically be discriminative. For example, you apply for a loan and you don't get the loan because you're black, or you want to get out of jail, and an algorithm decides it is better if you stay in jail, and does that based on the fact that you grew up in a certain neighborhood and so on.
Mm-hmm.
And that's the whole, basically her argument is that we need to audit. Actually, she has founded a company auditing these algorithms so that they are fair. And I just want to, maybe for next time the discussion or chip that in as a discussion point.
Yeah, we had a discussion on that on the European Meetup, I think the one before the last one. And that's very, there are some horrible scenarios for algorithms that decide stuff that you don't want to have decided by biased. But actually, it's often the case that the decisions are biased at the moment, and the data is used to create models. So it's not the model that is biased, but it's the data. It's the data that people are creating, and all those biases people have is going into those models.
Can you, Philip? Can you post the link of the podcast?
Yes, I will. It was data framed. I will do that. I will Google it. Data.
That'd be interesting to listen to, because one of the modules on the Fast.ai course was also around AI and ethics, and that was quite an interesting one. So that'd be quite handy. Thanks.
Yes, I will post it.
Okay, last call. Does anyone have anything else they'd like to share today? And if not, does anyone have anything that they'd like to share next Saturday?
I have a question for Nick.
Yeah, go for it.
Why did you choose a GPL license? It's actually quite restrictive. I mean, you can try software with it, but you can't use it in building anything.
I mean, it wasn't an easy decision, but it was what we settled on. It's what Linux uses. I'm not the first one to use that license, but it's part of our strategy, obviously.
Okay, thanks.
Okay, so I suggest we if we've got nothing else on, then we end a little bit early today. But please do try and think of something that you can perhaps demo or show next Saturday. That would be greatly appreciated. And also, if you can send that out in advance to the to either anyone who's hosting or on the in the Fast.ai DL what's the word, stream, that would just help us in terms of preparing what we can actually do for that week.
Maybe also proposals for things that can be done in the group, something like maybe a Kaggle competition or anything.
Yeah, so that's the weird thing. We actually did identify Kaggle competitions and which ones would make sense, but perhaps there are. I think it's just a case of everyone getting started in Jan, and I haven't. So there was some organization work that a chap did a lot of work on, but I'm not sure if anyone's actually gone ahead and used it. So
okay,
yeah, you can find details on the Fast.ai DL channel. There's like a Google shared document. What channels might Kaggle competitions might be interesting. Okay, excellent. Well, if that's it from any other last thoughts from anyone, otherwise I suggest we end a little early today and we catch up next Saturday. All right, thanks all.
Thanks for the opportunity to share. I really appreciate it.
Sure. Bye.